What is visual notification? In our last segment, we talked about notification in general and where we provide it. Notification is the output, the alert to hopefully inspire some action in our building occupants. We have audible output, which is the sound that alerts us to a fire event. Then we have visual notification. Let's talk more specifically about visual notification, which is where we'll spend much of the rest of this series. What is visual notification? When we think of visual notification, we often jump right to strobes. Visual notification could include signage such as scrolling LED signs or light up fixed text signs, but we'll talk more on those later. We sometimes refer to strobe coverage. Here we're talking about using light as a method to alert occupants of a non-normal event. While we all benefit from fire alarm systems that use flashing light to get our attention, the reason that we use light is to provide a sensory cue for those who are deaf or have hearing impairments, so that in noisy environments, when sound itself can't alert us to an event, we're going to know that something's going on. What is a strobe? A fire alarm strobe is a light source and a lens that directs light in a very specific pattern. The goal with the strobe is to achieve a certain level of light intensity for each area that it's placed in. The goal is to have a light intensity which is measured in lumens of at least 0.3725 lumens per square foot of area. Now, we don't necessarily have to cover every single surface within a room, especially when we think about environments that have a lot of furniture or obstructions, but we need enough light, whether indirect or direct, that can make it obvious to someone in the space that an emergency condition is happening. White light through a clear lens is the baseline for most fire alarm systems. We can tint the lens, though, so a colored amber or yellow light may be used in combination with other emergency systems. The clear lens is the most commonly used setup today. What is a lumen, and by extension, what is a candela? Both of these show up for fire alarm systems. A lumen quantifies the total amount of light emitted by a source in all directions, so it's a measure of the overall brightness. Candela measures the intensity of light, but only in a particular direction. A bare bulb and a flashlight may have similar lumens, that is, the total overall brightness might be the same, but the flashlight focuses its light so it'll have a greater candela value. That is, it's got a greater light intensity within a certain area. Let's talk briefly on the term synchronization. There are a few rules regarding light coverage from strobes. I mentioned the amount of light that needs to cover a space or a light intensity. Strobes also need to flash in a very specific frequency. The flashes must be no more than 2 flashes per second and not less than 1 flash per second. Any strobe that flashes must simultaneously flash with other strobes that are within the same field of view. So the common term here that we use is synchronized. People with epilepsy can have seizures or other significant adverse effects by significant flashing alone, but certainly that risk goes much higher if multiple flashes occur and they're offset from each other, coming from multiple directions. So if we can see 2 strobes within our field of view in one shot, what we can see, they need to be synchronized and flashing at the same time. Historically, fire alarm systems were not coming out of the box synchronized, and we often had to have an additional component added in order to synchronize a circuit. Modern fire alarm systems address this by design, and it's really less of an installation issue today. Coverage. In addition to light intensity and synchronization, here's perhaps an ill-defined area that'll take some engineering judgment. Are we allowed to have shadow areas, or part of a space that needs visual coverage but doesn't get it directly from a strobe? Well, yes and no. In an ideal world, we would have open and clear rooms void of anything that blocks a fire alarm appliance. But in the world we occupy, fortunately, we've got decorations, wall art, curtains, furniture, and then more practical things too, like kitchen service equipment, storage racks, ceiling fans, exit signs, cabinets, plenty of other things that can block light. The rule is that we need to achieve the light intensity on floor spaces throughout each area that needs visual coverage. Practically speaking, let's say we have a column that partially blocks direct coverage from a wall-mounted strobe. Could indirect light achieve that same required light intensity? Is it obvious to a person that's standing out of the direct path of that strobe that the fire alarm system is activated just by the light only? Sometimes that answer is yes, and sometimes it's no. If it's not obvious, we need to move the strobe or add more strobes to get the level of visual coverage we need. If we're unsure, go ahead and take a measurement in the space. Measure the light value. That can give us an answer. NFPA 72 talks about the level of light intensity, and it also talks about direct and indirect light coverage. Notably, we need to account for obstructions. So when we're talking about strobe coverage in rooms, it is the pattern of light produced on walls or floors that we need to pay most attention to. While when we're in corridors and people are already moving or already aware of a fire event, it's the viewing of the appliance that becomes important. If we're in rooms with strobe coverage, it's the pattern of light produced on the walls and the floors that we care about. If we're in a corridor, we want a direct view of that flashing strobe. Two different strategies there: rooms, corridors. So from a practical perspective, in design and review, we need to do our part to make sure we have visual coverage in the areas that it's required, and we need to account for the decorations, the furniture, and other obstructions that will likely be in that space. Does a small dental exam room need 2 strobes because there's a swinging overhead light that's mounted to the ceiling, or maybe an X-ray machine mounted to the wall that could block part of the strobe? No, that would be overkill. Would we possibly need to add more strobes if we're standing in the middle of a warehouse aisle with 25-foot racks and we can't see any flashing light when the fire alarm system's activated? Yeah, we would. Each of these requirements come from NFPA 72, Chapter 18. We get requirements for install, locations, strobe coverage, pulsing, flashing frequency, and synchronization. So for this one, what is visual notification? Well, visual notification is a supplement to audibility for fire alarm and mass notification systems. It's providing a flashing light to make occupants aware that some kind of non-normal condition is occurring. This method of notification is a benefit to all of us. The need for it is driven by people who are deaf or have hearing impairments, where they're reliant on light sources rather than audible cues. I'm Joe Meyer. This is MeyerFire University.
This has been a preview of MeyerFire University. Join the next generation of fire protection experts at www.meyerfireuniversity.com.